Hello everybody, welcome to Guidancee Education channel. We will see the topic that is discussed in this video. We are continuing class 11 physics, motion in straight line, chapter 3. Under that, uniform motion. The subtopics are velocity time graph, acceleration time graph, significance. These topics are very important, so watch the video without skipping. And if you think the video is useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now, and also press the bell button and all button for notification of more videos like this. Thank you very much for your support. Come, let us start the class. Uniform motion in one dimension. Velocity time graph, that is v-tgraph. Here I am discussing uniform motion. In some books, uniform motion and non-uniform motion are discussed alongside, that is together. But I thought one might get confused when both these types of motion are discussed together. So here I am restricting my class to uniform motion in one dimension. After finishing this, we will pass on to non-uniform motion. We have discussed position time graph for uniform motion in the previous video. If you have not yet watched that video, click the I button in order to watch that. Now we will discuss velocity time graph for uniform motion. By the by, what is the meaning of uniform motion? Covering same distance in same interval of time. That is uniform motion. That is, the object is moving with the uniform velocity. Velocity is not changing. What is velocity? Velocity is equal to displacement by time. That is delta x by delta t. I have given one illustration here. Let us develop this illustration. We will note down the time and the corresponding position on this line. The unit of time is second. 1 second, 2 second, 3 second, 4 second, 5 second, and so on. Displacement is measured in meters. At 1 second, it is at 1 meter from the origin. Second it is at 2 meter. Third second, it is at 3 meters. At fourth second, it is at 4 meter. And fifth second, it is at 5 meters. These distances are measured from the origin. Origin is not shown in the diagram. What does this tell you? During the time interval of 1 second, the object is moving in a straight line for a distance of 1 meter. So delta x by delta t is same for all these points. So we say the object is moving with uniform velocity. So in this case, we get it as 1 meter per second. How do we represent this on a graph? Y-axis represents velocity and x-axis represents time. Time is noted on the x-axis to a suitable scale. Velocity is noted on the y-axis also as per a scale. Here the velocity is uniform. It is 1 meter per second for the first second, second second, third second, and so on. So those points are marked. So for all these time intervals, velocity is the same. So when we draw a straight line to connect these points with the y-axis, we will get a straight line parallel to the time axis. Here we have marked up to fourth second. These are the points and it is connected. So what is the shape of the graph? For uniform motion, the velocity time graph is a straight line parallel to the time axis. I hope it is clear. What is the significance or use of velocity time graph? Area under the graph gives the displacement of the object. In the graph, I have shown velocity, which is uniform for the first 4 seconds. For each second, it is equal to 1 meter per second. In order to get the displacement during that time interval, connect the points 1 second and 4th second to the x-axis. It gives a rectangle. Area of this rectangle gives the displacement of the object during that time interval. That is length into breadth. That is 4 into 1 meter equal to 4 meters. So the displacement between first second and fourth second is 4 meters. Let me remind you in advance that when we come to non-uniform motion, the shape of the velocity time graph will be different. Anyway, we will discuss that in a separate video when we come to non-uniform motion. Now let us see the acceleration time graph, that is AT graph for uniform motion. It is very simple because velocity is uniform. Therefore, delta V, that is change in velocity, is 0. Therefore, acceleration also is equal to 0. Acceleration is nothing but change in velocity divided by change in time. In simple terms, acceleration means increase in speed. Here, velocity is not changing. Therefore, the object is not accelerating. It is not increasing its speed. So, while we plot the graph, acceleration is taken in the y-axis and time is taken in the x-axis. Point 0 for time and acceleration is at the origin O. Time keeps on changing, but acceleration is 0. So we have to mark that on the x-axis. So we have to mark the graphical representation for acceleration on the x-axis. You see the green line there. That green line corresponds to acceleration. It should be on the red line. But here I have shown it slightly above the red line so that you understand it. Actually, the x-axis represents the acceleration. So the shape of the graph is a straight line and it coincides with the time axis. Such questions are asked in the examination. It is all very simple. The only thing is you have to pay a little bit of attention. The quantities taken in the y-axis and also the shape of the graph. Just recall the shape of the position time graph for uniform motion. It is a straight line inclined to the time axis. So you have all the three graphs together. Here you can easily compare and understand. For uniform motion in one dimension, velocity time graph is a straight line parallel to time axis. Position time graph is inclined to time axis. Acceleration time graph is a straight line on the time axis. If you think the video was useful, consider subscribing my channel, like my channel and also share it with your friends. Press the bell button and all button for notification of more videos like this. Thank you very much. We will meet in the next video with the next important topic. Till then, bye. Take care.